Rudolph Auto EL4. With standard sample holder. As soon as the system is powered up using the key switch, the initialization of the system happens. There is a keyboard under the cover here, and there is a switch here for turning on the auto collimator lamp. And this is the eyepiece to view the image of the alignment dot or the sample, and then small objective when we slide this arm out, which aligns with the stage. And there are 3 knobs on the sample alignment stage. There are 2 on each side, and there is 1 on the front. The 2 on either side are used to level the stage, to lift it from side to side, and the one in the front will tighten the stage in that position, and then this knob can be used to move it about the y-axis. And there's another knob here for lift, raising up or lowering the stage. This is z-axis knob, and this knob has to be rotated after loosening the Allen screw under the disc here using the 1/4 Allen wrench. So after the system initialization is over, the system prompts to insert a sample. So I have a sample here, which is 1100 angstroms, silicon dioxide on silicon wafer. I'm going to start with alignment. So to align the dot, I'm using both left and right knobs. So that's the white dot for the alignment purposes. I'm moving the left and right knobs, and by moving the front knob, the dot moves down by tightening it, loosen it a little bit, and then by moving the left knob, the dot starts to move to the left, and by moving the right knob, the dot tends to move. So I'm tightening the left knob, the dot tends to move towards the left. So loosen that one, and tighten the right knob, the dot moves to the right. With practice, the dot could be brought to the crosshair center in order to align the sample leveling. The z-axis knob is to be adjusted only when the sample thickness changes. When we adjust the z-axis, we should make sure that in a dark room, the reflected light ray goes through to the center of this detector arm nose piece. So once we press continue after the sample alignment, the system will respond with the version control. This system is capable of running at the wavelength of helium neon laser and 2 other wavelengths if necessary. I'm going to run a routine using a 1100 angstrom sample with silicon dioxide on silicon. When the system prompts with run, learn, and continue, start with run mode and enter the program to 0, and the sample specimen thickness is about 1000, and I know my sample is over 1100 angstroms. I'm entering the value. This routine 20 we'll calculate both the thickness of the layer as well as the refractive index of the material, which would be 1.462. So when we enter program number 2.1, the NU, the upper layer refractive index, is taken from the COM, which is about 1.46. You press enter. So the system will proceed to measure the layer thickness. If the sample leveling is not correct or the alignment is not right, the refractive index measurements will be different, and hence the reading could slightly differ. Now I'm going to change the sample with a layer of about 2,200 angstroms thickness. It's a Rudolph old sample I have here. So I'm going to measure the thickness of this layer. So for this, I just press continue and enter the approximate thickness, 2,200, and proceed with the measurement. So this unit will display a cycle thickness which is 2,831 angstroms. This value is to be used when measuring a film thickness more than 2,800 angstroms. So the system will directly display the thickness for values below 2,800 angstroms. I have a sample here which is 9,470 angstroms, and demonstrate the unit is capable of measuring that thickness. So the refractive index is same. I press enter. So at any point of time the entered data is not correct, press clear. Or you can press
John Meyer, calling line 1. John Meyer, calling line 1. John, line 1.
So this unit, the Auto Yield 4, is capable of measuring the thicknesses above 2,800 angstroms, and it displays the thickness value directly.